Hi folks, we're going to take a look at this question from the homework. So they give us these two triangles that are connected by the line RS. We're given two acute angles, one in each of the triangles, and we're given the fact that this total length here is 50 meters, and they want us to find RS. Okay. So first thing I've already established is that this line here, RS, is common to both triangles. Problem is that I only know an angle in each of the triangles. I don't actually know one of the side lengths, which was what would be needed to solve either one of these triangles. Okay, but I do know the total length of these two opposite sides to the two angles. Okay. I don't see any reason to work with the hypotenuses of either of these triangles, so I'm going to stick with working with these two opposite sides and this length here, RS, which is adjacent to both of these angles. So I'm going to be working with tan, all right? So I'm looking for this, this length here, so I'll call it X. That's what I'm looking for. And I'm going to need some sort of way to give a name to these two opposite sides. So if I call this side here Y, okay, I could call this opposite side Z, but there's actually a relationship I can use to not force me to use a third variable here. Is this length here is just the total 50 minus Y, okay? And so now what I've set up is I've set up a triangle that has two unknowns. If I want to solve for either one of these unknowns, clearly I'm going to need two equations. And so that's what we're going to try to set up, is we're going to try to set up a system of equations, two equations and two unknowns, okay? And I think it was pretty clear that we said we were going to work with tan. So I'm going to start with the upper triangle. So I can write tan of 32 degrees is equal to the opposite over adjacent side, so y over x. And then I can use the bottom triangle here to write a second equation. So tan of 26 is equal to the opposite, which is 50 minus y over x, which is the adjacent side. And now I have what I was hoping to get, two equations and two unknowns. Okay, not quite as nice looking as the ones we would have solved in the past, but keep in mind that tan 32, tan 26 just represent numbers. Okay. So let's see how we do it. I'm actually going to solve, so we solved a similar one in class. I'll do this one a little differently. I think last time I isolated x because it seemed like the easier one to isolate. But of course, if I isolate x and eliminate it, then I'm going to have an equation in y, which is perfectly fine. But what I'm actually looking for is this side length x. So if I can come up with an equation that has x in it, all the better. So let's do this a little differently and solve for the y variable here. So here I can write y equals, I'll just multiply x to both sides to get out of the denominator. So I'm going to have x tan 32. Okay, and I'm going to do the same thing here, multiply x to both sides. So I'm going to have x tan 26 is equal to 50 minus y. And now I'll just move this negative y to the other side to make it positive. And of course, I'll have to move this x tan 26 to the other side. So 50 minus x tan 26. Okay, and so now I've got the y's are both isolated, so now I can do a substitution. So let me substitute this x tan 32 in for y here. Okay, so we have x tan 32 is equal to 50 minus x tan 26. And now what we have is just a linear equation because my variables are just x. There's no squares, no square roots. Okay, again, keep in mind these tan 32, tan 26, they're just numbers. So I'm going to try to solve it without replacing tan 32 with an approximation. If you're more comfortable doing that, that's fine. Just make sure you're using 4 decimal places for each of these. Okay, but I'm going to try to do it without having to approximate till the very end. So I'm going to bring all the terms with x to one side. So let's bring that to the other side. X times tan 32 plus x times tan 26 equals 50. And remember that when we're adding together two like terms, we're really just adding together the coefficients. Okay, so this can be written as x times tan 32 plus tan 26. Okay, equals 50. So think of it, if this were 3x and 7x, I'd just be adding together the 3 and 7. I'm just doing the same thing here. And so now to finish this off, I just have to divide by this number, both sides of the equation. So I end up with 50 over 1032 plus 1026. And now I can calculate this. Now I'll make my estimate. Okay, the later I wait to make the estimate, the more accurate an answer I have. So let's get our calculator out. So here, make sure you're also inputting it into your calculator correctly. So the numerator is 50 divided by, but I'm dividing by this whole thing. So please make sure you open up brackets here. So it's 1032, okay, plus 1026, and close off the bracket from the denominator. And here we get 44.9, but I think the question asked that it be to the nearest meter, so about 45 meters. All right, so let's just do a recap here. Step number one was to realize that I couldn't solve this problem directly. Okay, so I did that by splitting up this 50 into these two sides, which happen to be the opposite sides to the two angles. Okay, so that allowed me to use only one variable to describe these two lengths. So y and 50 minus y. Okay, gave a variable name to the side I was looking for, and I set up a system of two equations in two unknowns. Okay, elimination, didn't, I decided to do it by substitution here. And what I did is I just isolated the same variable in both equations. This would have worked just as well had I isolated x and then solved for y. Okay, in this case here, we isolated y and solved for x. And again, as you're solving this, you can either use approximations for these tangent values if you want to avoid working with this notation throughout your equation. But if you're comfortable, try to keep them all the way through your equation and only make your approximation at the very end. Okay, that's it for this one.